Evaluate using the order of operations. You must be able to correctly do this, otherwise larger problems that you understand the steps for will be not attainable if you cannot do this. You must do multiplication and division first. So this is 36, this is 12, that's 24, and then minus 6. Divide everything by 6. So 36 and 12 is 48. 48 minus 24 is 24, and minus 6 is 18. Divide by 6 to get an answer of 3. You must be able to do complex fractions such as this. Complex, not the regular meaning for Algebra 2, which is square root of -1. But complex in terms of you have a bunch of fractions over a bunch of fractions. And you just have to do it a piece at a time. You're going to have to find the common denominator for the top fractions, and in this case you can use 12. So put a 12 in there for the denominators, and then adjust the numerators accordingly based on what you multiplied the denominators by to get the new denominator. So your numerators would be 9, and then this one would be 8, and this one would be 6. On the bottom, 8, 3, and 2. All of those will go into 24. And adjust your numerators accordingly. This would be a 21. This would be an 8. And this over here we had to multiply by 12, so that's a 36. Multiplied by 3, multiplied by 8, multiplied by 12. Once you get to that point, you have to simplify. So 9 plus 8 is 17, minus 6 is 11. 11 over 12. And on the bottom, 21 minus 8 is 13. 13 plus 36 is 49. When you divide by a fraction, you can flip and multiply by the bottom. Also, don't forget you can cross cancel when you're multiplying fractions. 12 into itself once, into 24 twice. Giving you a new problem of 11 over 1 times 2 over 49. 22 over 49 is the answer. Absolute value symbols. This is not 19 minus 101 plus 311 minus 41 minus 1 minus 21. These are absolute value brackets here. They are written taller than everything else to signify such. You must simplify what is inside the absolute value brackets down to just one item before you can apply the absolute value. So in here we'll have 9 minus 10, which is a -1, and then plus 3 times the absolute value of -3, 1 minus 4, and then minus just the absolute value of -2. Whatever comes out of the absolute value, when you dwindle it down to one item, must come out to be positive. So the absolute value of -1 is just 1. Absolute value of -3 is 3. And the absolute value of -2 is 2. From there, it's a very simple problem. 1 plus 9 minus 2 is 10 minus 2, which comes out to be 8. Plug in -2 for A. So we get this. And then over here we plug in -6 and get this. What is the absolute value of -2? 2, and then we square it. Absolute value of -6, 6, and square it. So 4 minus 36 should be a -32. Plug in what you know. A is -2, so we have 3/4 times the absolute value quantity of -2 plus the quantity squared of -6. All of that over the quantity squared of -2. Keep in mind there is a dramatic difference between -2 squared and the quantity squared of -2. When you're inserting negatives into variables, you should put parentheses around the item that you put in. Otherwise, you run the risk of doing this and getting an answer such as -4, after you should have squared the -2 to get a +4. So whatever the case, you're going to go back through it here and simplify. This is -2, and this would be a +36. So you're going to get a 34 out of there. And then on the bottom, you're going to come up with a +4. So the absolute value of 34 over 4 is simply 34 over 4. You can reduce this 3 over 4 times 17 over 2 to get 51 over 8, or something else that would be equivalent. For example, 8 into 51 6 times with 3 left over. This problem is a guess and check problem. Insert one or more pairs of parentheses to make a true statement. 3 plus 6 times 2 minus 4 plus 7 times 2 is not -7. You have to make it true by inserting parentheses, like this, somewhere in this problem that encompass 2 or more items. So you could start by doing something like this. You could put parentheses here, and then work out the problem and see if you get -7. If it does not work out, try something different. Maybe another set of parentheses somewhere. Try it again. See if it works out. You could work this as many as 1, 2, 3, 4, 5, 6, 7, 8, 9 plus times before you get the right positioning for the parentheses. If you zone out after about 2 times and decide it's too much work to continue on, then you can't get the right answer. So you have to stay with it and keep track of what you've done on your paper. You may take a half a page just to figure out, where they belong. I'll just pick one at random and we'll see if it works. And I'll do that in black. And then I'll show you the answer, the real one, in red. Not knowing or remembering what the answer is, I'm going to try this first. If I did that, I'd have to do 2 minus 4 to get a -2, and then do the rest of the problem. 3 plus 6 times a -2. That would be 3 plus a -12. 3 plus a -12 is a -9. -9 plus this 14 would be 5. Is 5 equal to -7? No. So you would put the parentheses elsewhere or add in another pair of parentheses with it. You can use more than one set. But in this case, the problem turns out to be having a set of parentheses there and a set of parentheses there in red. That will give you the right answer.